Everyone, in today class, I have decided to take one most important topic related to the respiratory respiratory and ventilator equipments. One is that measurement of residual volume. Okay, so whatever we discussed so far, whether it is spirometer, and we have discussed lot of stuffs like lung volume and lung capacity, how can we measure. And we know one thing, that is spirometer, right? A spirometer is the most dedicated experiment. It is a basic level experiment where we going to where we can able to analyze our lung volume and lung capacity, right? So this is the major importance of spirometer. But this kind of spirometer also have some kind of drawbacks and limitation. What is that? In the sense, the spirometer device will not give information about the residual volume. Okay, so the reason is that in spirometer, during the set of procedure, the device will able to assess the exhalation property. That is, even we do the deep exhalation. Okay, at the end of, or if we are starting the equipment, even at the end of exhalation, we are not able to measure what is the air which is remaining in the lungs. That is all about the residual volume. So spirometer which is lag in that area, it means that it will not the spirometer is not meant for measuring residual volume. Other than residual volume, tidal volume or inspired reservoir volume or expired reservoir volume, everything we can measure. Okay, so the whatever parameters or the capacities or the volume which is being involved with the residual volume, which is that type of volumes or capacity, it's not able to measure by the spirometer. As I said before, the reason is that in spirometer, it's we are just blowing the air, and so the inhalation property at normal condition or deep breathing condition we can able to assess. But the what type of air, the what amount of air which is remaining in the lungs is still mystery. Okay, still it's very big question mark. We can't able to find with means of spirometer. So that is the reason we have some other techniques or measurements we will follow when you want to measure residual volume. That is the main motto of this particular class. We are going to discuss those techniques and measurements here. Okay, so it may so what are the techniques or measurements which we are using to measure the residual volume? In the sense, the first one is open circuit system, or you can also say nitrogen washout method. And second is closed circuit system, or you can also say helium dilution method. And third method is body lithosmography. Okay, so these are the three methods which is highly used to measure the residual volume. Okay, so before getting into these particular techniques, first I would like to have some detailed information about what is meant by residual volume. I think I have already taught you, but even then, I would like to repeat once again what is meant by residual volume, why it is so important. Okay, so residual volume is a something which is something it's a kind of remaining gas which is present in the lungs even after deep exhalations. Okay, that is even after end expiratory reserve volume. If there is any leftover of gas in the lungs, in the sense, then it is because of residual volume. Okay, so the it is a nature, it is the making like that. Our human being structure is designed in such a way that the lungs which hold some amount of gas, even the maximum effect of expiration at the end of expiration. The reason why the structure is made in such a way, in the sense, we have rib cages, right, over the lungs. We have the rib cages. So already we know that the lungs having very good recoiling property, elasticity property. So it's almost like a balloon. Okay, it will inflate, it will deflate whenever we are doing inhaling and exhaling. So consider balloon, when you are blowing the air, it will start to inflate. Once you will releasing the air, what will happen, it will like get collapsed with each other, so it will shrink in such a way. So the same concept, it will be the same concept applicable to our lungs also, because almost it's similar to same, the both having similar properties. So lung also, when we inhale, it will get inflate, and exhale when it will get deflate. So while doing exhaling, that is in condition of deflate, the lung should not collapse, okay, because we have a sharp objects like rib cages. So what will happen when we don't have residual volume, that is remain some amount of gas which will keep the lungs at a minimal inflate condition. So if there is no residual volume in the case, the what will happen, the lungs will start to recoil or get stuck inside the ribs, or there are high chance or high risk for the lungs to even to get rupture, because these are the bones, okay. So the lungs are like soft tissues, so there are high chance or high tendency for the lungs to get ruptured by me because of the bones, okay. So to avoid this, the nature have designed in such a way like to hold some amount of air even after end of the expiration, so it will prevent the lungs, okay, from recoiling or shrinking, recoiling inside the or shrinking inside the bones, okay. That is the beauty of making of having a residual volume inside the lungs. So this is the concept, this is the importance of residual volume. So it is very important to measure the residual volume. That is the reason we have so many techniques that we are going to discuss in this class, even in forthcoming class, okay. So if the person doesn't having this proper residual volume means, then the patient will be at the risk, because at any time, at any chance, the lungs will get ruptured as because of its recoiling property, okay. So in next class we will have a in detail discussion about what are the different measurements or techniques which is being involved in measuring residual volume. Until then, bye bye.